I'm Danielle Royston, and this is Telco in 20. If you get any three technical people together, they will always find something to fight about. When I was a coder, yes, I was actually once a coder, there were always huge religious wars about which coding environment was best. For example, if you bring up VI or Emacs to a group of programmers, almost always shouting and disagreement would erupt. It's like Marvel versus DC, Coke versus Pepsi, or Star Wars versus Star Trek. Everyone has an opinion. P.S. I'm an Emacs girl. When it comes to charging, we get just as intense. Seriously, we do. You can't just pick any database. Charging is a high volume, highly transactional business process where the database is a really important technical decision. You have to think about access patterns, speed requirements, the amount of data you need to process, how resilient the thing needs to be. The database is a core, fundamental, and key decision that you make in the design of your system. And when it comes to charging, we've got three main players at war. There's the traditional, old school, relational database, like Oracle. Womp womp. Then there are some people out there with their proprietary in-memory data store approach. And there's me over here with Totogi and DynamoDB, a non-relational, NoSQL cloud database. Well, today on the show, we have Alex DeBrie, a DynamoDB expert, to walk us through the pros and cons of each approach. And without giving anything away, I'll give you one guess to which way I think is right. I can't wait to talk to him, so let's take 20. Alex DeBrie is principal of DeBrie Advisory. He's also the author of the DynamoDB book. Hi, Alex, and welcome to Telco in 20.
Hey, DR, thanks for having me. Great to be here.
Yeah, I'm so excited. This is going to be a great conversation, kind of a technical one, and I'm going to dust off my computer science degree for 15 minutes.
Good.
It's so fun. So to start, as I just mentioned, you wrote a whole book on DynamoDB. And so tell me a little bit about how you became a DynamoDB expert.
Yeah, I always say it was an accident. I backed into it accidentally. My first job in tech was data engineering. So I was doing data pipelines and more like OLAP databases, like Amazon Redshift, things like that.
Yeah.
But then I was working for a company called Serverless Inc. They make the serverless framework, which just makes it easier to deploy serverless functions, AWS Lambda, things like that. And most people were using DynamoDB in these serverless applications just because some of the limitations of Lambda, it worked a lot better with Dynamo, where you have a HTTPS connection, it works with IAM, provisioning, billing, all sorts of things rather than a relational database. Mm-hmm. So I'm figuring that stuff out and I'm doing it wrong a lot of the time. And then I see Rick Houlihan give a talk at reInvent. Rick's been on your show before. Yeah. It just sort of blew my mind. And I watched that 8 times. And then I came out with this site, the DynamoDB guide, of just okay, this is how I understand Dynamo, because I didn't understand it correctly. And it just sort of snowballed from there. People started reaching out and things like that.
That's super cool. Well, I'm a charging girl. We're going to talk about telco charging today. And what brings you to the podcast here is telco charging, and especially the charging engine, is a high volume, transaction heavy application where speed really matters. And so the database you pick is not like a throwaway decision. It actually really, really matters. And it's an important technical decision in the design of the application. For example, at Totogi, where I'm acting CEO, we picked DynamoDB. And the other competitors are using other types of database approaches. And so it's a little bit of a religious war because everyone thinks everyone else is doing it wrong. And so everyone's like, those guys suck and ours is better and this is our secret sauce. So I wanted to just have a little dialogue about the pros and cons of these different approaches.
Yeah.
There's basically 3 approaches going on in the charging market today. Some of the vendors have selected an in-memory data store approach. This is like a proprietary database in one of the competitors, for example. Then there's, of course, tried and true traditional relational databases like Oracle. I think everyone's pretty familiar with that SQL-led approach. And then there's us at Totogi. As far as I know, I think we're the only ones that are using a NoSQL single table database. And obviously, as I mentioned, DynamoDB is our selection. So I wanted to talk with you about the trade-offs of these different approaches, especially when it comes to charging. let's first start with an in-memory data store. What do you think about this approach, about some of the things that you should think about, especially when it comes to charging?
Yeah, sure. So in-memory is super interesting. I usually see that in caching type use cases. With in-memory, you're going to get a lot more speed than a more disk-based database. The thing I'd worry about there is just durability, right? At some point, you have to get that to disk, and when are you going to do that? Are you doing that on the initial write? Or are you doing that asynchronously, and then can you lose data, and is that acceptable? I'd worry about the proprietariness of doing that. If you're a telco company or a charging company that's building your own database, that's a lot to bite off in addition to all the other stuff you have going on.
I think that's actually a really good point, that proprietary nature of that database, because charging is a tough problem in its own right. And so that's not necessarily a database specific thing, but like any sort of proprietary technology, when you're selecting a vendor, making sure that they can fund the innovation. This is typically a 10-year decision when you pick a charger.
Yep.
It's right in the heart of the network. It's right in the heart of monetization. And so it's not something that you swap out lightly.
Yeah.
You want to make sure that the vendor you select has a good runway and funding and can manage that. So moving on to everyone's fallback position, which is the relational database.
Yep.
Again, very popular, especially Oracle's one of the largest tech companies in the world, and obviously rests heavily on those laurels of a great database. So tell me about the advantages and disadvantages of using maybe a relational database in a high transaction processing kind of environment.
Yeah, absolutely. So relational database, very common, probably doing 80, 90% of applications out there, not cloud charging, just all the applications out there.
Very popular.
So a lot of people, using relational database. The great thing about it is it's very flexible, right? You have this normalized abstracted schema, and then you think how I want to access it later down the line. Maybe you add indexes and things to make certain things faster. It's easy to ask different questions, but in this particular world, talking OLTP, we're talking extremely high read and write volume against this. Now that the relational stuff is starting to work against you a bit, you don't need that much flexibility. You know the exact access patterns you're going to have.
Yeah.
Initiate a call, end a call, send some data, different things like that. So you don't really need this generic one. What you need is something more designed to the task at hand. And at the scale you're talking about with cloud charging, you're going to have to get rid of some of those features of a relational database anyway. You're probably going to have to be sharding across multiple different nodes here. You're probably not doing joins. You're probably not going to be doing aggregations or other things that relational databases can do, but some other NoSQL databases can't do. So at that point, you're sort of replicating a NoSQL database, except
you're not.
Yeah, exactly. You're dragging around all this other stuff and you're managing it on your own, and you're hoping someone on your team doesn't use a feature that they shouldn't use and pull the whole thing down and all sorts of things like that.
Well, I think those relational databases, like you mentioned, it's a little bit of a double-edged sword, right? That flexibility sometimes bites you in the butt. Can I say that?
Yeah, totally.
Where it's really easy to modify the schema, especially on an individual basis. This is my database. And so let's add an extra customization or extra field. And so that flexibility comes and bites you because people do it. They're like, I can. And so I will. And so the minute you start doing that, that starts to impact your performance. It impacts your ability to quickly upgrade. And sometimes you need to take away those tools because people use it and it hurts you. It hurts you performance wise.
Totally. And that's what we saw with Amazon.com, AWS generally. They were really hitting the limits of what they could do in a relational database in Oracle. They were having issues on Prime Day and Cyber Monday and all that stuff, to the point where that's where they designed Dynamo internally. They then productionize it, make it DynamoDB on AWS. But if you want that consistent performance, if you want to be able to scale linearly to whatever you have, you're probably going to need to use a more NoSQL database like that, or really abuse your relational database in different ways.
Well, yeah, I think Oracle's going to hate my podcast today, but Amazon very famously switched off their Oracle databases.
Yeah.
I think there's a video on YouTube, we'll put it in the show notes, where they were celebrating like turning off the last Oracle database.
Yeah.
I mean, it wasn't so much like we hate Oracle, we're moving off, but more of a impacting our ability to scale, and we need a different answer.
Yeah.
We were just chatting about this before we started recording, which is the number of transactions that they now handle with DynamoDB for like Prime Day, which is when people are ordering on Amazon.com retail. It's hitting that DynamoDB. And I think you mentioned to me it was like 89 million requests per second or something.
Yeah, at peak for Prime Day across those Amazon.com services, they peaked at 89 million requests per second against 2 DynamoDB. They did trillions of total requests across Prime Day. It's just quite amazing the volume that they're able to handle there and not have downtime issues.
Well, it's super epic.
Yeah.
So again, charging is, the database really matters in what you select, right? We were really thoughtful and intentional
Sure.
And so when we were looking at Totogi, we wanted to build a charging system that could literally handle the world's charging, right? Like Vodafone became a global provider in every country. Could you handle the world's charging? And we're like, number one, you need cloud. Absolutely, right? You can't build this in someone's data center, but you also need a badass database. And so we went with DynamoDB. And so we approached you. That's how we know each other, right? We approached you to get your thoughts on our design. So third, now let's talk about DynamoDB. Why do you think NoSQL, non-relational single table database is like chef kisses awesome for charging?
I think there's sort of two reasons to talk about. One is specific to NoSQL, and then one is specific to DynamoDB.
Yeah.
So talk about NoSQL. With a relational database, it's generally kept on a single server, and you just sort of have to scale up that server, but you reach the limits of any particular server size you can have. So at some point, you need to shard your data across multiple nodes by some particular key, customer ID, or something like that. And that's what DynamoDB is going to do. It's shards on this partition key very transparently under the hood for you. And it allows you to linearly scale your database. And no matter what NoSQL database you're using, whether it's Cassandra, DynamoDB, MongoDB, they all have that basic sharding setup. But I think what's interesting and unique about DynamoDB is it's proprietary to AWS and it's offered as a service, but it allows them to sort of pool all their different customers across their infrastructure within a particular region and share that capacity. And they can just build much higher level tooling on scaling up, scaling down your different databases. It's not like a single tenant instance-based database like you would have with a relational database, or even with Cassandra or MongoDB, where they're going to be putting that on an instance for you. You're not sharing with neighbors. But then if you want to scale up, well, now you have to spin up a new instance, reshard your data, all these different things. Dynamo's sharing that across all their customers in the region. So even if you double, triple, 10x, 100x your traffic pretty quickly, Dynamo can scale pretty rapidly to handle that, and you're going to be a drop in the ocean compared to all that's happening across their entire region. If you look at Amazon.com retail, the other different huge customers they have, all that stuff, they can handle that pretty transparently.
Yeah, I hear how people are always like, pew, pew, you guys suck. DynamoDB isn't the right thing. One thing they bring up all the time is, well, DynamoDB is not ACID compliant.
Yeah.
And so what do you think about that?
I mean, two things I would say to that. DynamoDB does have ACID transactions now. They've had those for a couple of years, and you can do that. But also, you're doing extremely high volumes of operations like you're going to be doing in cloud charging. You probably don't want to be doing a lot of transactions no matter what you're doing. You're going to try and limit that just to avoid contention on groups of items, things like that. So Dynamo, if you're working on a single item at a time, you're going to get those ACID characteristics that you want. So you can model your database in a way to handle that stuff.
And I think something else that you mentioned there was sort of the cloud nature of DynamoDB.
Yeah.
In our case, with Totogi and with DynamoDB, this is a cloud database, right? So the resiliency, the failover, the scale up, the capacity is all managed by Amazon as a service. And so what's so nice about that is we literally just writing coattails of Amazon, clearly with 89 million requests per second, right?
Yeah.
I mean, this thing is internet scale.
Yeah.
And so I think that's another really great point on DynamoDB that you made there.
Just one little anecdote to bring that home that Rick Houlihan always mentions. He shows this one performance chart of a company during the Super Bowl. You know, they had run a commercial. They were expecting a ton of traffic and what that looked like. And they were seeing that actually their performance got better during this spike because the shared request router layer was able to cache some of their configuration information. So even though traffic is spiking to this enormous amount, their performance actually got better rather than degrading, which is just like pretty wild if you're thinking about that for a database.
And that is what I think telcos worry about with capacity in their database. Just to give you a little bit of history, typically these applications are installed on premise. There's a team, a set of people that do like a dimensioning exercise. How much capacity you're going to need over the next 3 to 5 years? What are the spikes you're going to see? How are we going to fail over? And you buy all these servers and months go by. And what really strikes fear in an IT person's heart is that we did the math wrong on capacity.
Yeah.
Network usage ebbs and flows, right? Like it could be anticipated. You know, we have Mother's Day coming up. And so lots of people are going to be calling their moms and staying on the network, talking for a while. But then there's those unexpected events like a flood or some sort of natural disaster where people are trying to get a hold of loved ones and you have that spike. And whenever you haven't pre-provisioned the capacity to handle the demand, you'll have an outage. And that's where customers are really upset at their telco of like, I couldn't get through.
Yeah.
And so that's what they're really fearful of is that miss. And like you just said, with DynamoDB and Amazon, It gets better with scale, right?
Yeah.
We don't have that problem. And we don't have to pre-provision it. I'm not paying for it to be up and running. I just scale as the demand increases. And so it's awesome.
Yeah, once that Super Bowl ends, you turn it back down your usage and you're not paying for that peak usage. Whereas like you're saying, the on-prem one, you got to get those servers 6 months in advance. You're probably way over provisioning because you don't want to go down on the Super Bowl or Mother's Day or whatever we're saying. Exactly. And now you've got a bunch of servers that are doing nothing the rest of the year.
That you paid for and they're just timing out, right? You got to refresh them no matter what in 5 years or whatever it is.
Yep. And someone's going to pay for that down the road and it's going to be your customers.
Yep. It's crazy. Well, I was looking at your background and what's sort of crazy was that you were not a CS technical guy from the start. No. You kind of took a little bit of a turn at the beginning and you were a corporate lawyer.
It's true.
Tell me about that change, because making a change from being in the legal profession all the way over here to like talking databases all day long, was that a scary move for you?
Yeah.
How did you decide to make that leap?
Yeah, that's a great question. So I definitely don't have the CS background like you do, but I would say that law actually isn't that much different than programming. Often, especially like corporate law, you're basically like following all these if-else statements to figure out how things work like that. So in terms of like practicalness of making that change, my last year of law school is when I started to get into programming, and I was working on a startup with two buddies of mine. Yeah. And I worked as a lawyer for a year and it was fine. I enjoyed it. But my wife was also a lawyer. We had a couple kids. It was a really hard lifestyle. And I really liked programming a lot more. My brother-in-law was working at a startup here in Omaha. I made the jump over there. And
that's awesome.
I just love doing that work a lot more. It's so fun to just be able to create stuff out of nothing at any given day, where corporate law, I've only done it 9 months, but it was starting to feel repetitive. Every M&A transaction is kind of the same. Once you've done one, you've done them all.
Yeah, I mean, I sort of did the same thing. I have this computer science degree from Stanford, arguably one of the most valuable degrees in the world. Mm-hmm. So I did authentic CSE sort of stuff for, let's say, maybe 5 or 6 years. And I moved into HR, which no one does ever, but I did. Yeah. And my mom was like, "Are you nuts? You went to school for this thing?" But, you know, I look back on my lifetime of experience and it's actually made me who I am now.
Totally.
It's made me a better leader. And so hopefully you're having that same experience.
And I'm sure you know, being a leader of a tech company, just being able to understand the technical concept and what's possible, what's not possible, what's hard, things like that is super useful.
Yeah.
For me, having a law background, it's a lot of reading a ton of information, figuring out the important things and being able to write it out clearly of like what matters. And I think that was super helpful in writing the DynamoDB guide and writing the DynamoDB book, and also design reviews and things that I do now. It's a lot of writing, a lot of communication. A lot of the skills are the same there.
But I think you're right. At the end of the day, it's just following a bunch of rules.
It totally is. Yeah.
So anyways, Alex, it was so great to have you on the podcast. Thank you for your insights and thanks again for coming on.
Likewise. Thank you, DR. I loved it.
Awesome.
Stick around because we're ending each podcast with a Telco in 20 takeaway. I have 20 seconds to tell you something you need to know. Not to beat a dead horse, but to beat a dead horse. Like Alex said, one of the reasons why Totogi, built on DynamoDB, is so great is because it uses a cloud database, which the other guys do not. That means besides getting awesome technology built into the design of the actual database, you get all this other cool shit. Like, you don't have to support the database stack. AWS does it for you. It's available in 26 geographic regions. And as they build up more regions, they have 8 more planned. They proliferate that service. You can get it anywhere in the world. And it has scaling, resiliency, and failover built right into the service. On the other hand, just compare that to the way Telco has traditionally deployed charging. You have to stand up each stack individually, procure all the hardware, buy the database licenses, set up all the extra capacity, and don't forget to think about resiliency and failover. Not at Totogi. Because we use DynamoDB, our database has all of this built in, provided as a service by Amazon. It's totally badass. Go read about why Gartner thinks cloud databases are the future, much to Oracle's chagrin. We'll put a link to that in our show notes. This is the future. And if you want to talk to me in person about these amazing concepts, I will be up in Windsor next week flapping my gums with the Telecom TV boys at DSP, the Davos of Telecom. Hello, so cool. It's going to be a great event. High-level discussions with executives. There will be a fun party. I'll be there. I can't wait. So jump on a plane. And when you land in London, DM me on Twitter at TelcoDR. You can also connect to me on LinkedIn. And if you have any questions about Totogi or charging, you can also give me a call or WhatsApp me at 925-TELCO-DR. If you love this podcast, subscribe on Apple Podcasts and follow us on Spotify. And don't forget to sign up for our totally awesome 50% open rate email newsletter at telcodr.com. Later, nerds.